Now let's consider this example. Don't forget, mathematics is not a spectator of sport. In mathematics, with maths, you have to be ready to sit down. First, be in class always. Copy your notes, understand your notes, and then solve questions. Solve questions. Very, very important. No pain, no gain. You see, mathematics is not a spectator of sport. Now let's consider this example. Given that root x minus 1, 1, and then root x plus 1 are the first three terms of a geometric sequence. First three terms of a geometric sequence. Find the value of x, that's the AB. Find the fifth term of the sequence and simplify your answer as far as possible. Now, if you have A, B, C, that is if you have three non-zero numbers, this is always in a GP if and only if. If so, this is in a GP if and only if. That is C over B equal to B over A. Very, very important. This over this is equal to this over that. Very important for it to be a GP, three non-zero numbers. Now in this case, what do you have? We have root x minus 1, we have 1, and then root x plus 1. So if this is our A, this is our B, and then this is our C, the necessary and sufficient condition for three non-zero numbers to form a GP, this over this equal to this over that. So clearly from here we can see that that is root x plus 1 over 1 equal to 1 over, that's 1 over root x minus 1. So this over this is equal to this over that. So this over this, that's what we have here, equal to this over that. So that's what we have here. Now from here, I want to find x, what should you do? We cross, multiply. You can pause the video and try the question on your own. So we have root x plus 1, we have root x minus 1 equal to 1. Now this is difference of two squares. Either we use difference of two squares or we expand using the distributive property. Now we know that, you see, if you have a squared minus b squared, this a minus b, a plus b, that's difference of two squares. So if this time this, then this is equal to that. So from here, this is difference of two squares, or if you like, we can expand. Now let me use difference of two squares. So I take the negative, that's root x square minus 1 square, and this is equal to 1, because from here you'll be getting that. Now root x square, that's x, 1 square, that's 1, equal to 1. Now this crosses with x is equal to 2, or that's 1, this negative 1 coming, that's positive 1, and clearly 1 plus 1 is equal to 2. That's it. That's very, very easy. Either this or some people are not getting it. Well, let's expand. You see, we have root of x plus 1, and then we have root of x minus 1 is equal to 1. We expand using the distributive property. This time everything here, so we have root x minus 1 plus 1, root x minus 1, and this is equal to 1. Now root x times root x, that's x. This time this negative root x. This time this, that's root x. This 1 times negative 1, that's negative 1. And this equal to 1. Now what can we see? Is that this and that is cancelling. So you have x minus 1 equal to 1. So clearly x is equal to 1 plus 1. Negative 1 crossing positive, x is equal to 2. So that's the first part, our A. Our A says that we should find the value of x. Wow, very, very easy. Don't forget, this video together with other videos are available on the pen drive for sale. Very, very affordable. You see the numbers you are seeing on the screen. Please Call the numbers for one. Very, very affordable. A lot of all the topics I explained: mechanics, vectors, sequence, and series. Everything, elective maths, everything is on a pen drive for sale. It's not expensive. Very, very affordable. I've taken my time. I've explained everything. I've solved a lot of questions. More challenging questions are solved. Call the numbers. Are you going to write your WASI? Are you going to write Novdec? Please call the numbers for one. Very, very affordable. Now let's consider the B part as well. What is the question B saying? Now, the B says that we should find the fifth term. We should find what? The fifth term of the sequence. Now we are being told that this is a geometric sequence. Geometric sequence. So clearly, we know that for geometric sequence, our general term is giving us ARN minus 1. This is our general term. Now, we want to find the fifth term. So U of 5, the fifth term, that's AR5 minus 1. The n is 5. 5 minus 1. So this is the same as AR to the power 4. Now, the sequence given to us, we have that's root x plus 1. We have 1. And then, no, the first one is root x minus 1. And then we have root x plus 1. But in this case, we are being given that the x is equal to 2. We had x to be equal to 2. So let's put the 2 over there. So we are going to get root 2 minus 1, 1. And then root 2 plus 1. X is 2. X is 2. So we put it over here like this. Clearly, so we have AR to the power 4. You can pause the video and try this question on your own. You compare your answer with my final answer. Now, clearly, what is our A? Our first term. This is the first term, which is root 2 minus 1. That's the first term. And then we need to find the common ratio, because we have AR to the power 4. We want to find the common ratio. That's this over this or this over that. So that's root 2 plus 1 over 1. This over this. And we have it to be equal to root R. That is root 2 plus 1. Root 2 plus 1. Root 2 plus 1. Or, you see, or, you know, our R is the same as this over this. That's 1 over root 2 minus 1. But we know that this, we can't leave it like this. We have to rationalize. So this is times root 2 plus 1 over root 2 plus 1. We have to rationalize, and clearly this time this that will give us root 2 plus 1, but then the denominator always, that's difference of 2 squares, so that will be root 2 square minus 1 square, and root 2 square we get in 2 minus 1, which is 1, so the same as root 2 plus 1 plus 1 plus 1. So that is our R. Now we know that our U of 5 is AR to the power 4. AR to the power 4. Now, what is our E? What is our E? Our first term, that's root 2 minus 1. What is our common ratio? What is our common ratio? Our common ratio is this, which is root 2 plus 1, and this is to the power 4. We need to simplify this. Now, clearly, we have that's root 2 minus 1, and then this, we want to expand using the Pascal triangle. Now, so we are going to have that's root 2 to the power 4 plus. Now, the first one, the power has to decrease, and then the second one, the power has to increase. So we are going to have that's root 2 to the power 3. It was 4 to reduce by 1, and then 1 to the power 1 also coming, plus we have root 2 to the power 2 to decrease by 1, 1 to the power 2. As the first one decreases, the second one increases, plus we have root 2 to the power 1, 1 to the power 3, and then plus root 2 to the power 0, 1, 2 to the power 4. Now we know that 4, when it is to the power 4, you see when it's to the power 2, the equation becomes 1 to 1. So you see 1 plus 2, we have 3, 1, 2 plus 1, 3, and then we have 1. When it's to the power 4, start with 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and 1. So this would be the coefficient 1, 4, 6, 4, 1. So the coefficient here is 1, this one is 4, this is 6, this is 4, and then the coefficient here is 1. That's very, very interesting. So we have root 2 minus 1. Now root 2 all to the power 4, we can use the calculator, and this is just giving us 4. This is just giving us 4. Now you see we have 4 times root 2 all to the power 3 times 1. We can use the calculator, calculate this, and clearly this will give us that's 8 root 2. 8 root 2, because here that will be root 2 times root 2 times root 2, root 2 times 2, that's 2 times 4, 8, and then we have our root 2 there. So we have this. Now this one becomes square 2 times 6, and this will be 12 plus. You see what you have here? Root 2, 4 times root 2, so that will be 4 root 2 plus. Now this to the power 0, 1, so we have 1 over here. So we have root 2 minus 1. Let's see, 4 plus 12 plus 1. So 4 plus 12 plus 1. Then 8 root 2 plus 4 root 2. That's what we have here. And we have that's root 2 minus 1. You can pause the video and try the question in 4 plus 12, 16 plus 1. And we have 78 plus 4, that's 12 root 2, that's 12 root 2. So we expand this using the distributive. We have to simplify using the distributive property. So this time this we have root 2 times we have 17 plus 12. Root 2 minus 1, 17 plus 12 root 2. Now this time this we have 17 root 2. Root 2 times root 2, that's 2 times 12, and we have 24 minus 17. This time that's 17 minus 12 root 2. Now from here, you see we have 24 minus 17, 24 minus 17. This and this is coming here, plus 17 root 2 minus 12 root 2. Now what is 24 minus 17? And clearly this is giving us 7. This is giving us 7. That is 24 minus 17, that's 7. And then 17 minus 12, we have 5 root 2. So there's the answer. So we have simplified as far as possible. If simplified, there's nothing for us to do. Now when you punch this on the calculator, you will not be getting this answer, and you wouldn't get all the marks. You wouldn't get all the marks. So make sure that you expand using the binomial expansion, that you use the Pascal triangle. Very, very easy. A lot of questions like this. Very, very nice questions. A lot of past questions are solved. Everything available on a pen drive. It is very, very affordable. Mechanics, permutation and combination, calculus, everything from Form 1 to Form 3, everything, matrices, linear transformation, everything is available on a pen drive. Very, very affordable. If you are learning, you don't understand, probably you've gone to class, you are not okay, you'd put the drive in your device, and then you watch the video. The one that you don't understand, you pause you go back for better understanding, please call the numbers you are seeing on the screen for a copy. It is very, very affordable. A lot of questions are solved, past questions, a lot of likely examination questions, a lot of mock questions. Everything has been solved on a pen drive. Call the numbers for one.